Here I want to show you the equations for motion of a projectile. So typically what we have is a projectile which will follow a curved path as shown here in blue. So the projectile here is given an initial velocity of v0 at an angle theta, and as you could see here we have two components of the initial velocity, v0x and v0y, and you can calculate that easily by using the v0 cosine theta and v0 sine theta based on the angle theta. So let me go ahead and erase these now. So now basically what we need to determine for projectile motion is at any given instant what is the position or coordinates of the projectile, like x and y. Here this is x, this is y, and then also what is the velocity of the projectile, which is shown here, which consists of two components, vx and vy. So this is done very easily by saying that acceleration of the projectile is assumed to be only due to gravity. So we are neglecting the air resistance. So we are saying that the x component of acceleration is 0 and the y component of acceleration is negative g, or g downward. So based on this, if you go ahead and integrate, and if you integrate a sub x, you get v sub x. So v sub x, since a sub x is 0, basically v sub x becomes a constant, and that constant actually is v0x, which is v0 cosine theta. And then if you integrate a sub y, you get v sub y, and the integral of that is minus gt plus another constant, which is actually v0y. So actually these are the equations for the velocity. You have v sub x, which is this guy, and v sub y. And if you want the magnitude of the velocity, which is this guy, that would be simply square root of v sub x squared plus v sub y squared. So remember that if we neglect the air resistance, the x component of the velocity of the projectile at any instant would be a constant equal to v0x, and the y component is calculated based on this equation for any given time. So let's go ahead and now find the positions x and y, the coordinates of the projectile at any instant. So let me go to the next page. So now remember that we have vx equal to v0x, and we have vy equal to v0y minus gt. So how do we go about finding x and y? All we have to do is to integrate. So x is the integral of v sub x, and y is the integral of v sub y. So if you integrate v sub x, the integral of v sub x is v0xt plus a constant, and that constant actually is the initial position of the projectile based on the reference. We call it x0. And if you integrate v sub y, now remember v sub y is given as v0y minus gt. So actually you end up getting a v0yt minus 1/2 gt squared plus a constant of integration, which is y0. Typically you would write y as y0, so you go in this order, plus v0yt minus 1/2 gt squared. Keep in mind that we've already considered the fact that gravity is negative, and you just put the magnitude of gravity, which is 9.81 meters per second squared, or 32.2 feet per second squared. So this is the equation for the position, horizontal position of the projectile, and here is the position for the vertical position of the projectile. So now you have all the equations that you need to figure out the velocity of the projectile, v sub x and v sub y, and then we just determine how you get the position x and position y.